we are here to showcase our environmental DNA, how we use DNA to monitor species that are present.
We realised that there was a lot of research being done and it was being published in journals, and everybody said this is going to change the world of environmental management and biodiversity science, but they never told the environmental managers about it. So there was a need to sort of bridge that gap from the research that was being done to the people on the ground who might actually want to use these tools. So we set up Naturmetrics in 2016 to sort of bring those tools into a world where people could use them and make them accessible.
We can get information from wildlife through DNA monitoring, in that these animals, for example, the gazelle can be working in an environment. When it excretes, its DNA is transferred to the environment.
The biggest need for data is in the developing world, where you've got very high levels of biodiversity and also a lot of development pressure, so it's threatened, and there's a lack of tools to be able to understand it. So what we're trying to do is build a network of partner laboratories in countries where there's a lot of appetite for these tools, and train them up so that samples can be processed on a sustainable basis in the country without having to be shipped overseas, so it can be sort of, you know, a full system in the country.
Water has the ability to trap that DNA. From our sampling bags, we take water with this syringe, and then this is our filtration kit. It has ability to detect different kinds of DNAs that are in the sample. We carefully place it into the filtration kit, and then we are in the field, so we have to preserve it. We get it to 2 drops of preservative, and then we just carefully close it and take to the laboratory for sequencing.
So predominantly animals at the moment. The animals are the most developed assay, so particularly fish and animals that live in water. But we also actually get, especially in forest environments where you've got rainfall and the rain washes the DNA from the land into the river, you pick up the terrestrial animals as well. So you can get monkeys and bats and all sorts of things in the water. But of course, when you collect your sample, you are picking up the DNA of everything. So actually you've got the DNA in there of your phytoplankton, your zooplankton, bacteria, fungi, plants. So, and all of these contain really useful information about perhaps water quality and all sorts of things. So we can develop assays that also look at those groups from the same samples.
We can only monitor what is we know.
I've been doing it non-stop for 3 years, and I'm still amazed when we get data off the sequencer at how much it's able to pick up and how well it's able to describe communities. You know, better than conventional method.
In Kenya, we have Lake Victoria. It's the largest water body, a freshwater body in Kenya. From that, when it rains, many rivers take water from there, from different environments. Then we can get water from there and sample it and get every kind of species that is present around. And from that we can know how many species for fish, for crocodiles that are present.
If you go to somewhere really, really diverse, like the Amazon rainforest, then in half a litre of water you might find 70 or 80 species of vertebrates.
Partner with us and discover the true potentials of eDNA research.
First partner is a laboratory that we can train to process samples. Once that's in place, then yes, we want to start, we've built a citizen science kit that can be used by anybody in the field, so whether that's sort of school children, local communities, anybody who's interested in monitoring and understanding their environment close to them. And we want to work in partnership with sort of local NGOs and governments and communities to be able to provide that kind of monitoring.